The key idea is simple. When a user paints with the contextual paintbrush, instead of changing pixel values, the model backpropagates to determine the change in latent parameters, which would result in the requested color change.
Okay? Think about that for a second. Got it? Parse that. Okay, so we've got an image. Normally, a paintbrush applied to the image changes the pixels. But they're saying, no, no, no. What if that image was the result of a generator? So there's a z vector back there somewhere. So let's take what the paintbrush is saying. The paintbrush is saying, change these pixels. But instead of changing them directly, we backprop. So we say, well, let's consider that a gradient. We'll take that gradient, backpropagate it through, and ask, how should we change z to try to accommodate those color changes? So we're going to take a step in z space, not pixel space. But as we've seen, interpolations in z space are semantically meaningful. We're following the manifold of faces or hair or glasses or digits or whatever it might be. And so these subtle brush changes end up not just coloring things, but like adding hair or removing glasses or changing gender or whatever it might be.
Then takes a gradient descent step in that direction, resulting in globally coherent changes. I originally developed this interface as a tool to explore the latent space of the introspective adversarial network, a novel hybridization of the VAE and GAN which powers this system. We can randomly sample the model to generate faces at will, then use the paintbrush to take walks in the latent space. Normally, if we wish to get specific repeatable changes in a generative model, the model needs to be augmented with attribute labels during training, as there is no guarantee that specific latent vectors will correspond to meaningful features. This works well for samples generated by the model, but fails when applied to existing photos, as the model's reconstructions are certain to be imperfect. We circumvent this problem with a simple masked interpolation, visualized here. The top row shows the model's reconstruction, the reconstruction error, and the original image, and the bottom row shows the changed reconstruction, the difference between the current output in the reconstruction, and the final output photo. The output is a composition of the reconstruction and a weighted combination of the reconstruction error and output difference. By interpolating between the error and the requested change, we can get smooth, realistic changes in the original photo. As with all such techniques, your mileage may vary, and you can end up with results such as Bizarro Hitler or them, but for the most part, results are stable. If you'd like to know more about the IAN model, see my paper, and check out GitHub if you'd like to run or modify the photo editor yourself. Thanks for watching.
Yeah, so that's like a really creative way to use this technology, and I thought very fun. So let's see, I think that's actually